welcome to the workshop component of our lecture on correlation and measures of association. And I want to show you right now in Excel really quickly, first of all, how to do a scatter plot, and then secondly, how to use Excel to calculate the correlation coefficient R and the coefficient of determination R squared, and then do a t-test to see if, to test the null hypothesis on the correlation coefficient. So as you can see here, I've copied and pasted over, highlighted here on the left, a few columns of data, of hospital data, or California hospital data, and I've taken the beds staffed and the beds occupied, right? And so for each hospital, I have the hospital IDs here, and then the numbers for those hospitals for the staffed and occupied beds. So if you want to create a scatter plot like I have done right here, all you got to do for these two columns is you can just scroll to the bottom if you want and select the data like that. Go to this Insert tab at the top. You want to insert a chart, a scatter plot, and you just click that and insert the chart, right? And this is one of the best ways to start out analyzing data, because right away, as soon as you look at this chart, you know that there's a clear linear relationship between the beds that are staffed at these hospitals and the beds that are actually occupied. And so it's also nice when you create a chart to pick a chart type that has some labels, right? So you could type in the axis titles. Our beds occupied are in the vertical axis here, and our beds staffed are in the horizontal axis. So you type that in. You could type in a nice title like I have in the red chart here. And so the main thing is, when you look at these two charts, you know there's going to be a very strong positive correlation coefficient because of the way these dots follow a line, right? As a hospital's beds that it staffed increase, so too do the beds that it actually occupies. And this is probably not surprising, right? We would expect hospitals in high demand areas to have a lot of beds staffed. Interestingly, though, there's a good deal of literature that shows that hospitals that build more beds also tend to fill those beds, because if you build it, they will come. That's the thinking anyway. Okay, so that's how you calculate the scatter plot. The next question is, well, how do you create a correlation coefficient, right? I've calculated the means right here, taken the average of the beds staffed and occupied, and I could go through and demean the data by subtracting the mean from each of these values in column B and C, squaring it, and going through the lengthy correlation coefficient statistic. Or I could just calculate it in Excel. And so you can see here I've already done this. What I want to show you for the correlation coefficient is Excel will calculate that for you based on some rows of data. So what you do is you go to the Formulas tab. You want to go to Insert Function. And if you just type in correlation here and hit Go, it's going to suggest functions to you. And so here we're just interested in the correlation coefficient. You select this thing called Correl. You could also select Pearson as well. Let's select the correlation coefficient here. And so anyway, select this, then you click on Array 1 in the data. Oh, you got it. So this is a good memo to me. When you do this, you have to make sure that you click on two different rows and use the formula appropriately. So let's go back and redo this. Okay, so I want to go to Insert Function. This correlation thing here, in Array 1 you want to select, so basically you can see you select two arrays of data. So you have to do them separately though. You got array 1 right there, and then you go to array 2 and select the data like that. Make sure you select all the data. All right, and then you just hit OK, and it does all the work for you, which is nice. And so, you know, as I mentioned in the lecture, R squared is pretty easy to calculate off that. You would just take the square of the correlation coefficient to get R squared. So that's easy enough to do. The next thing you want to do is a t-test though, right? And so remember our formula for a t-test. T-statistic is equal to the correlation coefficient multiplied by the square root of n minus 2. That's in the numerator. In the denominator, you're taking the square root of 1 minus r squared. So we already got this. You want to type out the, remind yourself the null hypothesis is that rho is equal to 0. You can calculate your n, your sample size, just by counting up the rows and subtracting 1 for the header row. Here we have 441 observations, minus 2 degrees, minus 2 gives us our degrees of freedom of 439. So to fill in the formula, we want to know what the square root of n minus 2 is. And so to do that, you type in this function up here, sqrt, and then in brackets f11, we got the square root of n minus 2. If you remember the numerator, we're multiplying the correlation coefficient r by n minus 2. So that's what I'm doing here in the numerator, right? I'm multiplying this cell right here, the correlation coefficient, by the square root of n minus 2. And that gives me the numerator for the t-statistic. The denominator, if you remember, is the square root of 1 minus r squared. So we got r squared here, 1 minus r squared, we can put it within this square root function. So here I'm doing 1 minus cell F4, which is where my r squared statistic is. I'm taking the square root of that, and that gives me the denominator of the formula. So the t-statistic then is that numerator divided by the denominator. And as you can see, a t-statistic of 130 is enormous. So, you know, that's way, way, way over on the right-hand side of the distribution on the t-statistic. If you looked it up in your book, you know, your book only goes up to a certain point. You wouldn't even see it. So it's a huge t-statistic, certainly much greater than our critical value of alpha we're set at 0.05. So we end up rejecting the null hypothesis, and we conclude that there is definitely a strong linear relationship here.